Hello students, myself Chanel Popat. Let us begin new topic stability of slopes. Slopes here may be man-made or natural, but basically an unsupported earth mass or soil mass is known as slope. Now, stability of them are very much important. If you see any of landslides, they happen due to their instability, right? So stability analysis is very much important factor. Before learning anything new, you must understand their application or where do you apply the knowledge of this topic. So stability of slopes are important when we are constructing highway embankments, railway embankments, as well as canals, etc. structures. So let us understand them more thoroughly. So I will start the lecture with earthen dams. Here, this surface of earthen dam can be more steep. More steeper surfaces are more safer, but too much step is also not safe. So you have to decide steepest slope with proper stability for any structure. So this is earthen dam. You have to provide soil mass here and that also should be stable. Same way when we are discussing railway embankments, there is also a slope. It cannot be too much flat, it cannot be too much steep. Same way, if you are going through a riverside or canal bank, you can see the slope. Again, slope of the canal is very crucial for water resources engineering. So, these are basic ideas and applications of stability of slopes. Let us move to next thing, which is reasons of failure. Now, there are several reasons of failure. Let us discuss them. Action of gravitational forces. Here you can see one figure. In this is a formed soil strata. Here by these green lines I am showing kind of grass. So you can understand this is a soil strata. Now whenever soil mass will be there, it will try and move downwards due to gravitational force, and these component of weight will make your soil mass fail or unstable. Then landslide will occur. Another one, that is seepage forces within soil mass. Now if the water table as the inverted triangle is showing, here it is water only and water is going through these area. So these seepage will make the slope unstable because the moving water is here and this soil is above that. So this soil will not be so much stable and that can be a failure. Excavation or undercutting of its foot. Sometimes when you are constructing or excavating, you do construct or excavate at wrong places. At wrong places means if you cut foot of a slope, then slope will be unstable and it will come downwards. Disintegration of the structure due to weathering. Sometimes after long time due to weathering, like some areas having heavy rains or heavy winds, there may be due to weathering, the disintegration will make your slope unstable. So this is also a failure of slope. Forces due to earthquake. Here, when earthquake occurs, earthquake will occur in horizontal direction as shown, and weight of soil mass or weight of earth mass will be in downward direction. So both of them will cause unstable slope due to earthquake. And anyway, you can understand due to shaking also slopes may get unstable. Sudden lowering of water table adjacent to slope. So sometimes by water table reduction, or we can say water table lowering. Water table, if you can see this inverted triangle and this one, before 2 days the water table was here and after 2 days it went down. Then this slope will be unstable and it will cause a failure like this. So these are several reasons of slopes getting failed. So moving forward to finite and infinite slopes, let us understand them. If a slope represents the boundary surface of a semi-infinite soil mass, semi-infinite means if you are watching a mountain and a mountain is too steep and lengthy, then you may think it is semi-infinite kind of thing, right? And soil properties for all identical depths below the surface are constant or may be assumed as constant is called infinite slope. Actually, in field there is no actual infinite slope, but some very long slope mountains are assumed as infinite slopes. And if the slope is to limited extent, or it is only up to limited extent where you can reach or easily you can see that it is finite slope. For example, we can say slopes of earth dam where you can see it easily. Canal banks slope, it is also visible easily. So these are finite slopes. So factor of safety is very important in engineering because human tendencies are like using resources on maximum scale. If you are making a building for 5 people, the human tendency will tell you to use it for maximum scales or use it moreover than that. So we have to keep factor of safety in all our engineering. Now, in geotechnical engineering, in slopes, there are three types of factor of safeties are used. First, FOS with respect to shear strength, FOS with respect to cohesion, and FOS with respect to friction. Let us understand them one by one. They are important in stability of slopes. Factor of safety with respect to shear strength. Formula for that will be Fs is equal to tau F by tau, where Fs is factor of safety, tau F will be maximum shear strength which is available, and tau which is mobilized shear strength. Tau F and tau can be defined by tau F is equal to C plus sigma tan phi and tau is equal to Cm plus sigma tan phi m. Here, shear strength chapter gives us the formula C plus sigma tan phi, right? And here tau F there is maximum available strength, and here tau means mobilized, whichever is used, or we can say ultimately used, which is mobilized. Here C will be Cm and phi will be phi m. Phi m means phi mobilized and Cm cohesion mobilized. Furthermore, Fs can be written as tau F formula C plus sigma tan phi upon tau formula that is Cm plus sigma tan phi m, where Cm that is mobilized cohesion and phi m that is mobilized angle of internal friction, which we have talked before a minute. Moving forward, let us analyze this equation like this. Cm plus sigma tan phi m make that a subject, we can get this. Now, if I divide both of them individually by Fs, we can get this equation. Now, Cm can be defined as C by Fs and sigma tan phi m can be defined as sigma tan phi by Fs. Here, if the soil is purely cohesive, you can use the upper formula, and if the soil is purely non-cohesive or cohesion less, you can use this bottom one. Here Fs is equal to C by Cm and Fs can be written as tan phi by tan phi m. Sigma sigma will be cancelled, that is why we can write Fs is equal to tan phi by tan phi m. So this is factor of safety with respect to shear strength. Now factor of safety with respect to cohesion, and which will be named as Fc. Here Fc is equal to C by Cm. We have discussed it earlier. Where Fc, we know that factor of safety, C that is available cohesion and Cm that is mobilized or or utilized cohesion. Now, FOS with respect to friction. F phi can be written as sigma tan phi upon sigma tan phi m. Now, sigma sigma can be cancelled out and F phi will be tan phi upon tan phi m, where F phi is known, tan phi or phi, that is angle of shearing resistance, and phi m, that is mobilized angle of shearing resistance. Types of slope failures. First type, rotational failure. When earth mass or soil mass fails in kind of direction in rotational direction, it is known as rotational failure. Now, rotational failure is divided in three types. First, phase failure. Now, when the weak plane of soil slope will be above the toe, above this point, above the toe, it will phase fail, or we can say it is a phase failure. You can see a blue line which is a failure line which is going above the toe. It is not touching the toe. In second case, toe failure. It will pass through the toe, or we can say weakest plane is passing through the toe and failure line is also passing through the toe. Then it is known as toe failure. And when weakest plane and failure line is passing below the toe and taking the toe with that, it is known as base failure. You can see a base failing here. So these three types are basic rotational failure types. So in most of the cases, toe failures are seen. So toe failure is very much applicable in the field. Second failure, that is transitional failure. Here two planes will transit. In infinite slopes, the failure plane will move like this. Here you can see in the figure, the soil mass, earth mass is getting transited in between two planes. It will happen like this. In third case, compound failure. Compound failure is basically combination of rotational failure and transitional failure. When both effects are on your earth mass or soil mass on slope, both the effects will together act and will make a compound failure. You can see the shape of both coming into picture. Next failure, that is wedge failure, where wedge failure is almost like a transitional failure. A distinct wedge will come out of the slope, or it will slide down the slope. A wedge, or we can say a substance or a piece of slope will come out. Here, transitional failure will only occur in infinite slopes, where wedge failure may happen in finite slopes also, where weaker planes are like cracks or fissures in the rocks. It can happen like this. Miscellaneous failure. Apart from all these slope failures, some failures are very complex to understand. These are miscellaneous failures. We can say spreads. Sometimes whole slope becomes like a spread. It spreads in the soil very easily and no failure symptoms or no failure reasons can be found out. It is very complex to analyze. Or we can say flows are also occurring from mountains or from slopes. Right? So that's it. In this lecture, we will understand more theory in next video. Thank you.